Good morning.
Good morning.
Good morning, girls.
Good morning.
Good morning.
Okay.
Good morning.
Good morning.
Morning.
Good morning, Jim. Okay, girls. Before we continue, any questions? Or let's say it's okay before we start. Any questions? Now, I hope you girls are aware that on 13th is your quiz, second quiz, which is going to be chapter 6, 7, and 8. Clear? So chapter 6, chapter 7, chapter 8 are going to be the 3 chapters that we will have on your next quiz. So pretty much what we have done until now, from chapter 6, chapter 7, chapter 8. Okay, girls. Any questions? Yeah. Okay, and the format of the test is as it has been, multiple choice. Okay. Okay, girls. So are you guys ready to go on to the next chapter? So goes the next chapter is going to be chapter number 9. And which means going to talk about or call sound beams. Now girls, since we since this whole is about ultrasound, that's why they use the word sound. But the reason that they use the word beam is because, as remaining can say is that as the sound waves are being transmitted or emitted from the transducer, it will also attain some behaviors of a beam. Okay, so in this chapter, what we mainly is are going to do is mainly talk about what we mainly can say what will be the anatomy of a beam. Here, how is it that a beam mainly is going to look like? Now we can mainly say to understand a little bit about that, we say we have a PCT. Now in this chapter here is what they mainly is just also that if your transducer just had one single PCT, because we mainly is we say what is going to be the shape of a beam produced by a single PCT. Whereas when we go to our actual transducer, we actually see that as an actual transducer has anything in between us 250 to 450 pieces of PCT, where you can make says each piece of PCT will produce beams or wavelets, which actually is forms what we'll call a beam. So generally speaking, as goes, we can mainly say that a beam of sound waves is going to be like this. This is mainly as what a beam will be looking at. Okay. Is that clear? Now, as we most likely in the next chapter what we also will talk about is going to be pulses. Very mainly can say your pulses, that's me, just going to go like this. Okay, so these are as two separate entities, but yes, they will actually just go together. So pretty much as this was real pulse. Okay. But yes, as they travel, yes, they will mainly have this shape here, which is going to be the shape of your beam. We can also say that the reason that they call it a beam is mainly because it has the common similar characteristics as a beam of light, which is going to be easy to see. Okay. But this chapter here is mainly just as going to emphasize upon things such as we can call the anatomy of the beam. Okay. Anatomy of the beam. So that's that's going to be different areas of the beam as you see it here, which are going to go under it. There's different names. Okay, which mainly is and some of those name actually is are going to as a functional explanation to them. Okay, but generally speaking, go just whenever we talk beam, you will mainly is see me. It's draw something like this, which will be a beam. Okay, now goes physically, it's we are not going to be able to see a sound beam. You can say, here in a sound beam, here in a sound beam. It's not really something that is what you can call it going to be visible to you. Okay, but one thing that will be visible will be a light beam. Okay, so I'm just going to go into complete blackout mode. Okay, girls. Let's. Now, or even if you look here. Okay, that should. Okay, let me. Okay, no, I can't do that. Let me see, maybe that. Cycles. Just reduce the. Okay. Okay, that's okay. Good. That's better. Okay, girls. Now, why does this slide here? Oh, yes, okay. Why does this slide up? This piece of paper. Oh, okay, this thing shouldn't be taught online.
Is it because it has a high reflection?
Okay, but right now it's okay. No reflection. Oh God, this is not good. Okay, I guess I gotta go up. Okay. It's not doing what I wanted it to do. Let me see, maybe I have another one. A little smaller. Okay, maybe that's too small. Okay, let's try this one here. Nah, okay, I guess not. But practically, yes, okay, what they say. Even yes, okay, being produced by yes, okay, by a source of light. Mainly, yes, okay, is. It should be working. I don't know why. Should be working. I don't know why. Okay, but it is going to be okay, a piece of homework that you will do, because even if you yes, okay. Oh my fuck. Oh God. What happened here? Oh, okay. Hello, girls. Can you hear me?
Yes.
Okay, I don't know
Yes.
what the blue happened. All of a sudden, it disappeared. Okay. But girls, says, okay, if you look, at any area is okay where you throw the beam of light, as you may call it. That you may see is okay, the beam. Now this is okay, the whole, because that's okay, dimension of the beam. Clear? Okay. What you mainly as okay will see in the center is that okay, yes, it is brightest. Clear? And what you actually will see is that okay, yes, the brightness decreased brightness. As you go from the center where it's okay, the beam is brightest, towards as okay, the periphery of the beam. I don't know why it's not working. It should be. This is frustrating. Nah, okay. You may see here. Okay, now this is your beam. Right, okay. Where do you see? It's brightest in the center and then it just gets darker and darker and darker as you go towards the periphery of it. Clear? Okay. And some areas which is mainly as okay, what have been up here is going to be as okay. Very, 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 very dark. Okay, that's not going to work. That's why this thing shouldn't be taught online, but that's okay. Now girls, just have you said yes, okay, when we did chapter 5. Do you guys remember chapter 5? That way it's okay, a beam was brightest. Now I mean yes, okay, where we can say right, okay, why was it brightest? Mainly because of the greatest intensity. Clear? And what did we call this kind of intensity here? This was going to be as okay, the spatial intensity. Clear? And that's why I say yes, okay, when we said spatial intensity, yes, okay, that was all yes, okay, relevant to the beam of sound, or we can say it's okay, sound beam. Right, okay. So why beam? Yes, okay, mainly because it just acts like okay, yes, a light beam. Clear? Okay. As we said back then, yes, okay, in a hurricane. Where was it that you had, okay, as the maximum energy? That was in the eye, which most likely, as I said, it was going to be in the center. Clear? Okay. But the reason that we is okay, mainly is okay, call it a beam. Because okay, in its first part, as it is being emitted, what mainly is going to happen is that, okay, as we can say that the diameter of the beam is going to narrow down. Or we can say that the beam actually is, okay, becomes narrower and narrower and narrower and narrower. Then it reaches to, yes, okay, to a point where it is going to be, yes, okay, at its narrowest. And after that, it is mainly, yes, okay, going to, yes, okay, spread out. Right. And this here is, okay, mainly we can say, okay, make the three different regions or areas or zones of your beam. Okay. So let us look at it in this way. It says, okay, this was our transducer. And in this chapter here, so, okay, mean yes, okay, because we just started going to, okay, study the, is okay, what it calls, okay, the anatomy of a beam. Okay. We mean yes, okay, we just assume that we just had one single PCT, which is producing, yes, okay, its own beam. And why do we call it a beam? Mainly it's okay because it's going to, it's okay, attain. Oh, sorry. This shape here. Okay. Now the first area of the beam here, I'm just going to just, okay, change a little bit on the colors. And where we mainly can say it's okay, where the beam keeps on narrowing. Now what we say is okay when it is okay is narrowing down is that its diameter is decreasing. Clear? Okay. Is that clear, girls? This area here is okay where the beam is narrowing down. That is actually it's okay going to be as okay what we will call the near zone. Yeah. Okay. Did you girls get that? So what happens in the near zone? That is mean that's okay where the beam is narrowing down. Now this near zone here is okay also goes as okay under another name. It can be called the Fresnel zone. Now what did I say the other day? That okay, something may be known by more than one name. Okay, so for you girls, yes, okay. For you girls, you have to, yes, okay, remember that the near zone is also called the Fresnel zone. Some people may also, yes, okay, call it the near field. Okay, so that is okay, the near field or the near zone. Okay, but also it's okay known as the Fresnel zone. Clear? So that's mean it's okay going to be, yes, okay. Now why do they call it the near zone? Because that's mean it's okay going to be the zone of the beam, which is we can say is okay, close or near to the source of the sound beam here. Did you girls get that?
Yes.
And what happens in the DI and what is that happens in the near zone? We may just see that the beam keeps on narrowing down. What does it mean to narrow down? That it means that's is going to that the diameter of the beam is decreasing. If you just said, if we just say if you took a cross section of the beam at this area, at this point here, you could mainly says the cross section of this beam at this area here would be this big, for instance, right? Okay. Whereas if you said, if you took a cross section of the beam at, let's say, this area here, your main says this would have been the diameter of the beam. Clear? Okay. Whereas if we went further and says what about here? And it would just have been as a smaller diameter. So what mainly happens in the near zone is that the beam actually narrows down. Okay. Or what we actually is what this narrowing down here also can be referred to is that it can be called the beam actually is converges. Did you girls get that? Okay. And in the middle of this throughout, you can mean it is in the middle of the beam. Just as as I tried to show you. But that's mean is where we'll have the highest, oh God. Intensity. What kind of intensity are we talking about here? The spatial intensity. Okay. Just go back and look at your chapter 5, and that's it will be clear what I'm talking about. Clear? Right, okay, as I said, that's okay. Now, what mainly happens is at some point, the beam is going to we can say stop to narrow down any further. Clear? And that is mainly because the beam actually happens to reach to its narrowest point. Okay. So that's where the beam reaches to its narrowest point. That is going to be called the focus. Okay. So the point in the entire course of the beam where the beam is at its narrowest point that we can actually say, that if you for instance, took a cross section at this point here. You can make it says, this would be the beam. Which mainly mean that, yes, this beam here is not going to get any narrower than this. Because that would mean is, what we saw at the focus. Now it can be called the focus. It can also as be referred to as the focal point. Clear? Why the focal point means is because that is a point in the beam where it will focus. Clear? As far as as a beam is concerned, what does it mean to focus? That mainly means that beam actually is has reached to its narrowest point. Clear? Okay, so the focus that is going to be as okay, the narrowest point of the beam. Now, what does it mean to be as okay at the narrowest point? That will mainly mean that okay as smallest diameter. Or what we also says okay, because says okay, that's going to be the point of the beam where the beam actually has okay as the smallest area. Is that clear? And since this is the point of the beam where it has the smallest area, so we can say, okay, due to the smallest area. Okay, that's going to be, that is why that the focus, or what we also can call as, okay, the focal point. Okay, is going to be where the beam has the greatest intensity. Did that make sense?
Yes.
Right, okay. Why? Mainly because, okay, we said that earlier in chapter 3 that, okay, yes, intensity was inversely proportional to area. Here we have a greater 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 area. That mainly means that, okay, in all these areas here is okay, we will have a lower intensity. Because after all, it's okay, it was because it's okay, the same amount of energy. Okay, that was okay as produced, or power is okay, that was produced by the beam, but was okay distributed over a greater and greater and greater area. But since that's okay, the area here is okay, becomes lesser. Or we can say it's okay, the smallest area of the entire beam. Okay, where we is okay, we'll have okay, let's say the same amount of energy distributed. That's going to cause that okay, as that will be the area of the greatest intensity. Okay, so the focus, or is okay, what we can call the focal point in the entire course of the beam is going to be as okay, the area in which is okay. First of all, is okay, the beam focuses. What does it mean to focus? That it reaches down to as okay, the smallest area. Clear? Okay. And due to as okay, this smaller area or smallest area, that's going to cause that okay, yes, it will have the greatest intensity. What kind of intensity are we talking about here? The spatial intensity. The intensity in terms of space. Because all this here is okay, that's okay, yes. The space or area of your beam at, because it's okay, different points. Right. So the point at which the beam reaches its narrowest diameter, that can be called the focus, and or we can also call this point here is okay, the focal point. Did that make any sense?
Yes.
Good. Any questions?
No.
Good. So we said, okay, as this here. This was what we call, it's okay, the near zone. Then we reach to, yes, okay, what we call the focal point. Or we just call, yes, okay, the focus. And what mainly is okay, just happens, yes, okay, beyond the focal point or focus is mainly as okay that the beam is going to, yes, okay, spread out. Okay. Now, what do we call this area? It's okay beyond the focal point or focus. That is going to be, it's okay, called the far zone. Clear? Just like we also okay call the near zone. The near field likewise is okay. Your far zone also can be called the far field. We also said that okay, yes, your near zone could be called as okay the Fresnel zone. Likewise, yes, okay, does your far zone also have a other name which is going to yes, okay be the Fraunhofer zone. Yeah, but what mainly happens in the far zone is that okay, as the beam is going to yes, okay diverge. Clear? What would I mean? That it actually is okay, keeps on spreading out. Whereas okay, in the near zone, yes, okay, what happened was that the beam narrowed down. Or we could say as okay, converged. Until it reaches yes, okay, its narrowest point, which is going to be as okay, the focus point. Or focal point. Or focus. After which, yes, okay, the beam can narrow. It's not going to be able to, yes, okay, narrow down any further. Okay, so yes, okay, there only were two options. That's okay, since it can't narrow down for any further, it either had continued straight, but that's not going to be the case. No, the beam actually is going to, yes, okay, diverge out. Did that make sense? So what is it we actually see happens here is again is that as we go further and further and further, mainly because okay, the beam diverges more and 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 more. That actually is okay going to be as okay and increased. We can say it's okay and increasing decrease in the intensity. or it can mean that's okay. Okay, the intensity is okay, meaning as well keep on decreasing. So if you find that's okay, compare that's okay the intensity of here versus here. You say it's okay, all that's okay. In the far zone, that's okay. This area here had a greater intensity, and this area over here will have okay as a lesser intensity. Why is that? Mainly because here we have a smaller area, whereas over here it's okay, the beam has a greater area. Yeah. Which kind of intensities was it that we were talking about or referring to? Your spatial intensities. Did that make sense? Did that make sense, girls?
Yes.
Now, what we actually is okay, will say is that okay, as around your focal point, or what we call the focus, we actually have a zone. And this zone here is going to be referred to as the focal zone. Okay, this is going to be referred to as the focal zone, which is mainly as okay, just a zone around the focus or focal point. Okay, so that's okay. Any area of the beam is okay, which is around, or right next to you is okay, your focus or focal point is going to be referred to as the focal zone. Now, guys, what you have to remember is that okay, as because it's okay. One half of this focal zone here half of the focal zone is in your near zone. And we can say it's okay. The other half of this focal zone here is going to be in the far zone. Is in far zone. So if we actually said that, okay, yes, if we assume that, okay, yes, from here to here, our focal zone, for instance, okay, was, let's say, is okay, a total of 3 centimeters. That mainly means that, okay, yes, half of that 3 centimeters mainly means, okay, that this would be, sorry, 1.5 centimeter of your focal zone was going to be as okay in the near zone. And okay, the other half, which was going to be as okay, another 1.5 centimeter of your focal zone was going to be in the far zone. Okay, but the focal zone is actually is okay, an area or a zone around the focus. Okay, where half of it is okay extends into the near zone, the other half is okay extends into the far zone. We can say as okay, what if we had a smaller focal zone? Let's say as okay, our focal zone, for instance, okay, we just said okay, well, just 2 centimeters. It's still going to yes, okay, be half of these 2 centimeters here. It's going to yes, okay, half of that, which would be as okay, just 1 centimeter would be yes, okay, in the near zone. And okay, as the other 1 centimeter of your focal zone was going to be in the far zone. Did that make sense? Okay, and pretty much what you can say is okay, in the middle of your focal zone is the focus, or is the focal point. Or we can actually say that okay, the focal point or the focus actually is okay, the area of the beam that is going to do what? It is going to mean as okay, separate the near zone from the far zone. So the point where your near zone finishes is going to be the point where your far zone begins. What comes as a separated mark between the two is going to be as okay, the focal point or focus. Because what happened in the near zone was that the beam narrows down until it reaches to its narrowest point. And what happens afterward? It spreads out. What do we call the area where the beam spreads out? That is going to be referred to as the far zone. Clear? Okay. Okay. What happens at the focus or focal point? That is going to be as okay, the point in the beam that is going to as okay, focus on. Right, okay. What does it mean to focus on? That's mainly going to mean that, okay, yes, that's going to be the point at which the intensity of the beam is going to be maximus. Why? Because of the narrowest point. Okay, so back in, yes, okay, your previous chapter, that was why. That was why, yes, okay, the relationship between intensity and area was important. Because it becomes applicable now. Right, okay. Or let me give you guys, okay, an example. You can say, how many chapters, when we're done with this chapter, how many chapters have we done?
9.
9 chapters. Okay, good. Okay. Now you will say, well, okay, I have a quiz coming up. Right, okay. And I already told you, okay, what are the chapters for your quiz? 6, 7, and 8. Okay, so when you, yes, okay, now you're mainly going to say, well, okay, I need to focus on these 3 chapters here. What would that mean? If you say, I need to focus on these 3 chapters here because I'm going to come have a, I'll be having a quiz coming up, right? How you focus on these 3 chapters? you probably will, yes, okay, concentrate most of your energy that you use reading on those 3 chapters. Clear? And what does it mean to just, okay, concentrate energy on an area? That would mean that, okay, yes, you do more intense studies of these 3 chapters. Okay, so you can just, okay, talk about this and yes, okay, day to day, yes, okay, ways as well. Yes, okay, as I tried, but okay, yes, I guess luck was not on our way or on our side today. But it's okay, just go into a pitch dark room with a bigger or smaller flashlight and throw that light on outside a wall or something like that. And you will see, yes, okay, what the beam looks like. Is that clear, girls? Okay. But the reason that they call it, yes, okay, the focus is that's going to be as okay, the area where there's going to be as okay, a maximum intensity. Clear? Now, girls, when we yes, okay, go on to yes, okay, look at okay, yes, the diagnostic imaging. Or you yes, okay, if you are looking at something, now if you want to see that object clearly, what do you need to do? You're standing on the side of a road looking at the fields. Very straight surface. Which may mean that, okay, you can look for distance of miles and miles and miles and miles. Right? Right, girls?
Right.
Good. Now let's say yes, okay, in all that okay, yes, in all that area of the field, all of a sudden, yes, okay, there's a point that yes, okay, catches your attention. Not okay, yes, 10 miles away, not necessarily right in front of your nose. But yes, okay, somewhere in those fields, let's say yes, okay, you see a little butterfly or something, yes, okay, or a bird flying around. Now that catches your attention. What is that you're going to be doing then? You will be focused on that thing, right? What does that mean? That most of okay the energy that you use all this okay you could look for as okay several miles. Okay, but your attention is focused on that area where this bird or butterfly is flying. Did that make sense? So likewise, girls, it's okay on your imaging. On your imaging, you can say it's okay, well, I'm able to, it's okay, I have a field of view here, or a depth of view here, which is 10 centimeters deep. Which mainly mean that, okay, you are able to just, okay, see structures. Actually, it's okay, send the sound wave on a journey which is 10 centimeter deep. Okay. But within this 10 centimeter, they're going to be as okay, a point they say, well, like I need to look closer at this. That's going to be as okay where you will set your focus. And what does that mean? That the point at where you set your focus, that is actually is okay, the point that you actually want your beam to narrow down to its narrowest. Did you girls get that? Okay, so we can actually say that this is okay, that is your image. And we may say, well, okay, yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say it's okay that the depth of our image here is 12 centimeters. Depth of image, right? Okay, we said, okay, as was 12 centimeters. Okay, that you, yes, okay, still can, yes, okay, look on, yes, okay, the horizon of a field, which maybe is okay, if he says, okay, 12 miles. Okay. But at some point you say, well, okay, I want to focus at this depth here. I'll just say, it's okay, I want to focus at this area here. Because, okay, I may see as, okay, 2 children playing in the fields. So that's going to be as, okay, my point of focus. Right, okay, which may lure me that, okay, yes, you may still be looking at, okay, as this area here. Or which is like here. You may even still be looking as, okay, at this area here, which is here. Or we can say, it's okay, this actually is okay, this would have been, yes, okay, your near zone. Just like this was. Okay, and because it's okay, this here is okay, what still has okay being your far zone, just like as this one. But all this is okay, you say, well, okay, I'm going to focus at this depth here. So practically, it's okay if you look at it and say, it's okay. For instance, okay, if this here is okay, was your transducer. Okay, where we okay as have our, we can say it's okay, PCT. That PCT is okay, produces a beam. And mainly because, okay, you said, well, okay, I wanted to focus at this depth here. You set this focal point here. Okay. But what you actually is okay, will be doing or telling the system to do is, well, okay, yes, you send out a beam. But I want this beam to just okay, focus at this depth here. So this means that's okay, going to be as okay, the point at which okay, as the beam is going to be as okay at its narrowest. And then, yes, okay, it will diverge out. Did that make sense? Okay. Did you girls get that?
Yes.
Okay. So mainly as okay, if you look at it, okay, that in the near zone, yes, okay, what is going to happen? Yes, okay, the beam converges. Main is okay to reach to its narrowest point at the depth at which you, yes, okay, had set your focus, which will be as okay the focus, or what we also as okay call as okay the focal point. Focal mainly as okay is pertaining to, and here's okay the foc for focal mainly as okay is derived from focus. So focal mainly as okay just mean pertaining to focus, and point is point. Did that make sense? So that's going to be as okay where the beam will be as okay get to its narrowest diameter. After which it means okay, it just goes into the far zone. Did that make sense? Okay. So we as okay as sonographer actually is okay will be able to as okay adjust our focal point and say, well, like I want you to focus here at this depth. If you want to, you can even focus at this depth. If you want to, you can even as okay focus at this depth here. Which means okay, if you focus at, let's say it's okay, if this becomes your focal point. What I mean? Now I mean that okay, yes, your beam, yes, okay, will keep on converging until yes, okay, it reaches its narrowest point here. And then, so yes, okay, this will be yes, okay, it's near zone. This becomes the focus, and what do you have after that? Your far zone. Okay, but the focus or focal point in your image is going to be as okay the point at which the beam reaches its narrowest diameter. Did that make sense? So God, the reason that we call it a beam is mainly because it goes like this and then goes like this. What did we call the area in which it converges or narrows down? That is the near zone. What do we call the point at which it reaches its narrowest point? It's going to be the focus or focal point. And what do you call the area after that? It's going to be as okay the far zone or far field or Fraunhofer zone. Did that make any sense? Now, since at the focal point, the beam has its narrowest diameter, or we can say, okay, the area is okay, the part of the beam where it's going to have is okay, the smallest area. That is why it's okay, that would be the area of the beam where you have the greatest intensity. Which kind of intensity? Spatial intensity. Clear? Why? Because that's going to be the point where the beam is at its narrowest. Okay, so if that's okay, you forgot about that's okay, your chapter number 5, go back and look at okay as the first part of it, which talks about spatial intensity. They briefly as okay talk a bit about as okay the beam. Did that make sense? Okay. But you can mainly says, okay, well, okay, whatever is happening on the right, or whatever is happening right here, whatever is happening all over there, that's not going to just, okay, catch my attention. I'm not going to just, okay, waste my energy on that. Because I need to focus on what's right here. Because that becomes my focal point. Did that make sense? So practically goes as far as the practical part is concerned. Yes, okay. Okay. You as sonographer will be able to set your focal point. As a matter of fact, and okay, that's something that you will see later on, that we actually is okay, will be able, if you want to, you can say, okay, you can set 2 focal points, 3, 4, 5. Okay. The benefit of that is that you will be able to, okay, you can say, okay, focus at multiple points. Clear? Okay. But yes, okay, it may also is okay come with some disadvantages. So that's what we yes, okay, we will talk about later on. But it's okay, you will be able to, yes, okay, if you want to. Okay, you can be able to focus at this depth here. You want to say, it's okay, I also want to focus at this depth here. That's fine. Okay, so well, mainly what happened is, okay, as if you focus at, let's say, it's okay, this depth, mainly mean that, okay, at that point, yes, okay, the beam will, it's okay, come in, be at its narrowest here, and okay, then diverge out. Then, okay, yes, you also at the same time say, well, okay, I also want it, okay, to focus at, let's say, it's okay, this point here. But mainly what happen is that, okay, as your beam comes, and okay, as it will just okay diverge down to its narrowest point here, and then spread out. But then it always focuses here. Okay. Now the whole thing about that is that it happens so rapidly. It happens so rapidly that's okay. The eyes is not going to be able, it's okay to detect that. Okay, as it first focuses at one point, then it focuses on another point. Okay. So the details about all that is something that is okay. We will talk about later on. Okay. So is there anybody who is in doubt about, yes, okay, what a near zone is? What a far zone is? What a focal point is? Also known as focus. And what a far zone is? And what the difference between far zone, no, it's not far zone, sorry, focal zone and focal point was. So focal point is going to be as okay, that point or depth at which the beam focuses, where you can mainly say as okay, a focal zone is going to be as okay, a zone around the focus or focal point. Okay, which half of it just okay extends into the near zone, half of it extends into the far zone. Yes, my dear.
I don't know if I missed it or not, but did we talk about Or are we going to talk about the focal length, or we don't have to worry about that?
We coming to that.
Oh, okay, okay.
Okay. Focal length, the focal depth. Okay. But is there anybody who is in any doubt about any of the things that we talked about so far? Nope. Okay. So yes, okay. Go out into an open area and look on, okay, as far, okay, as the eye allows you to look. So that will be as okay, you can say as okay, your total depth of image. But then you say, well, okay, there's this area here. It's okay, where okay, some activity is happening. That's why you focus at. Or you can say, well, okay, yes, we did 9 chapters, but I'm not going to focus on chapter 1, 2, 3, 4, and 5. Because they call into us okay into the near zone. Okay, I'm not going to focus on, let's say, it's okay, chapter 9 and chapter 10 and chapter 11. Because they fall into the far zone. As far as okay as my quiz is concerned. Right, okay. Because there's going to be as okay, chapter 5, 6, chapter 7, and chapter 8. Okay. So how is it that you focus on that? You concentrate more of your energy upon that. Or you can say it's okay, I may stay as okay because otherwise I'm going to be falling behind. I may still read on chapter 8, 9, but it's not going to be as intense a study of chapter 9 that I would do when I compare it to okay, how intense I study chapter 6, 7, and 8. Is that clear? So that is just okay, that's your intensity, that's your focus. Clear? Okay. Now girls. So okay, yes. We could say, now usually it's okay when I draw the beam, it's okay, I just draw it this way. Anyways. We could say it's okay. This here is okay. That was what we just called the near zone. Then we can say it's okay, we have the focus or the focal point. And then we could say, okay, we have the far zone. Right, okay. Whereas, okay, as if you look on that in the image, where we mainly say as okay, we focus at this depth here. This is just okay where our focus is. All that mean that may mean that all this is okay, that's going to be as okay, the near zone. And all this here is okay. Is the far zone. All that mean that okay, as it's mainly as okay, going to is okay, that okay, as if this was our beam. that this would be the point, yes, okay, where the beam is at its narrowest, and then yes, okay, so this diverges all like this. Clear. Now, if we first, yes, okay, set another focal point and says, okay, our focal point was here. In that case, as okay, what will just happen is that, okay, yes, Vico says, okay, that then this would be, is okay, the point where the beam is okay, come to its narrowest, and then it would diverge out like that. Okay, so yes, okay, the focal point can actually, yes, okay, be set at a narrower or at a shallower depth, which may mean that, okay, yes, if this is our focus, then, okay, yes, what do you have? You can say, it's okay, this will be your near zone. If this is your focus, then, okay, yes, this becomes your far zone. Or you said, well, okay, what if you set the focal point here? You know what I mean? Okay, as the beam, yes, okay, as it travels, it will reach to its narrowest point as this depth here. And then after that, that's okay, that's where it will diverge out. So yes, okay, you can say it's okay that like this. So this here is okay, whole thing here is okay. It means that you will have a greater near zone because your focus at a greater depth. And then that's okay. It's just become yes, okay, your far zone. Okay. And what you actually is okay will be able to do on not all, not most, but pretty much okay, as every system. It gives you the option, or it gives you as okay the possibility to be able to focus at multiple depths. Okay. But this is mainly as okay what it means to just okay focus at a specific point. That's going to be the point where the beam is going to be narrowest. Now you may say, Mike, so you said, okay, let's say it's okay that we focused at this point here. What about all this area here? Well, let me just clear it out. There it says, okay, this for instance, okay, was our image, right? Okay, you said, Mike, okay, yes. You said that we focus at this point here. Now, what about all this on this side? And what about all this on this side? Okay. The question is that going to be out of focus? And the answer for that is no. So what your system actually is okay will be able to do is focus at everything that falls at this depth here. And why is that? Mainly because goals. If we say that, okay, yes, this here was your beam of ultrasound is going to go like this. So the beam is actually, that's okay, going to be moving like this. Okay, but since you had set it at a certain focal point, it remains says, okay, well, this is going to be, okay, the depth at which I focus at. Which means that, okay, yes, wherever the beam is going to, yes, okay, be going, this is going to be the point where it will be at its narrowest. But it'll be, yes, okay, when the beam is directed this way, this is going to, yes, okay, be the point of where it's going to be the narrowest. If it's directed this way, yes, okay, this is still going to be the point of where it's going to be the narrowest. At its narrowest. Along this whole depth here. Did that make sense?
So no matter where you point your transducer in the focal point, it's still going to be in the nearest, meaning high intensity in that area.
Mhm.
Okay.
Clear? Okay. So what you actually do is by that's okay, setting a focal point. Okay. That's mean as okay, going to be as okay, you set a depth at which the beam will be focusing at. Clear? Okay. But okay, that's something that we'll talk more about as okay in chapter, okay, my lord, that's I think chapter 12. That you will see that okay, yes, the beam is not going to be standing at one point, but actually going to go like this. Or just like, okay, as the light beam on a lighthouse. Have any of you ever seen those? Clear? What is it that a lighthouse does? Why did they have lighthouses? Listen. Yes, goes. They may not be that functional nowadays, but okay, yes.
They said in the past they have them to help to guide back people are at sea back to land or something like that. Mhm.
Exactly right. Okay. Okay. So maybe that's okay, guide. Or yes, okay. They could even use that and say, well, okay, yes. What ships, boats, vessels, yachts, exactly, that's okay. Do we have an area? Okay. Now the remaining says, okay, this area here, that's okay, going to be the job of this lighthouse to scan. So if it just had kept its light at okay at one point, it will say, okay, I can only see it's okay what happened here. That's why okay, yes, it will go like this. And scan okay as a bigger or smaller area. Okay. But here we can see as okay that since we set okay as our focal point at a certain depth, we made as okay determined that we want the beam that travels to as okay be able to as okay converge at this depth here to its narrowest. That will be as okay your focal point. Clear? Okay, so what happened at the focal point doesn't mean it's okay the point in the entire course of the beam is okay where it was at its narrowest. Did that make sense? Clear? So if we look at the beam. You're going to be see this diagram a lot and a lot and a lot. We said, okay, this was the lower transducer. We said, okay, this will be we made it, okay, said that this here is okay. So far we can call this okay the near zone. We say that this is okay, that is the focal point, or what we also called focus. And after that, yes, okay, what we mean is okay, just have is the we can say okay, the far zone. Right. Which is mainly as okay, we just for instance, okay, looked at an image. Then we say, yes, okay, if this here is okay, was our focal point. Right, okay. Now I mainly mean that okay, it's all this here. That would be yes, okay, the near zone. And all this here is okay, in this instance, yes, okay, will be the far zone. Okay. Now we also already know that okay, yes. This was okay as the depth of image. Okay, where we know that okay, that's going to be as okay 1 centimeter between dot to dot to dot to dot. Now goes when we say focal depth. Or when we as okay also can call it okay focal length. That is actually that's okay going to be the depth or the length from the transducer at which the beam focuses. Here, and what does it mean to focus? Where the beam is okay reaches to its narrowest diameter. So practically speaking, yes, okay, if you look at it, because okay, this near zone here can also, yes, okay, be measured in terms of distance or area, or whatever, right? Okay. What's the distance from, yes, okay, from the transducer to the point where the beam focuses? So that distance actually is going to be called the focal length or focal depth, because that's going to be the depth at which the beam focuses at. So if yes, okay, measure from here and here, say, okay, what is the length of your near zone? Let's say it's okay, 8 centimeters. That will mainly also mean that okay, yes, our focal length is also going to be 8 centimeters, our focal depth, because at a depth of 8 centimeters, that's when the beam focuses. Or you can again say, well, okay, go on to that field and say, well, okay, I'm able to look at a distance up to just, okay, 5 miles. Right? Okay, that field, yes, okay, that was okay, that's up to 5 miles that you actually say, okay, were able to clearly see. But then you say, well, okay, I'm going to focus at a distance which is just 2 miles away. So what, okay, me says, okay, that my focal point is 2 miles away. And what becomes, yes, okay, your focal length then, or focal depth? 2 miles. So focal length or focal depth is mainly as, okay, just the depth at which you focus at. Clear? What did it mean to focus at a point? Concentrate your energy at that point. Did that make sense? Now, any of you ever had photography as a hobby? And goes, unfortunately, it's okay for the relatively younger generation. I'm not talking about photography or a thing like this. No, actual photography, where you have a gadget like this. No. Because that's okay. Even in that case, that's okay. We'll say, well, okay, there are things in front of what I need to focus or want to focus at. And there may be things behind it or farther away in the field. But I want you as okay, focus at this thing here, which is at a certain depth or at a certain distance. So when we say focal depth, that is meaning that okay, that's going to be the depth in your image at which you are focusing at. Clear? And if you look at it, you can mean it says, okay, if this here is okay, what the point at which I focused at, then this distance here is going to be as okay, reference to the focal length, or as okay, the focal depth. Whereas, okay, as if I'm focusing at this depth here, or at this point here, we can say, okay, this is where my focal point is going to be. Then, okay, yes. Then this distance, that's going to be as okay, my focal length or my focal depth. Because the depth at which I am focusing at. Is that clear? So that's okay. In that case, we can mainly say, okay, that focal zone, no, sorry, focal, focal length. Meaning that's okay, measurement wise is going to be as okay, the same as your near zone. Because both of these here is okay, will end at the focus or what we call focal point. So what was the focal point or focal depth? You can measure it's okay, the depth at which the beam focuses. And what did it mean to focus? It mainly meant that, okay, as the beam reaches its narrowest diameter. That is contagious. Okay, so if you set your focal point at 3 centimeters, what is it that you're doing? You're mainly telling the system, well, okay, whatever you do, those beams that you send out, I want them to just, okay, converge onto their narrowest point at a depth of 3 centimeters. So that distance at which the beam is going to, okay, converge down to its narrowest point is going to be referred to as the focal point of focal length, which actually is going to be as, okay, the same that is going to be referred to as your near zone. Because what happens in your near zone? Beam converges, beams narrow down. It reaches to its narrowest, and then after that, spread out or diverge. What do we call the area in which the beam is, okay, spread out or diverge? That is going to be referred to as the far zone. Clear? Okay. Why do you want to just, okay, focus at a certain point? Mainly just, okay, see clearer. Now, those of you who are wearing glasses should know. Because what happens if you take out your glasses? Most things are going, as okay, or you can say it's okay. Actually, it's okay. What you're not going to be able to do is visually focus. So that's okay. Things are going to start looking blurry. Why that? Mainly because, okay, those light rays that passes through your eyes are not going to be able to focus. Okay, all comes around the point of focus, that's okay, on your retina. So that creates as, okay, those blurry, as okay, you're not going to be able to see things clearly. So the same happens here as, okay, you want to say, okay, this is the area that I want to see clearly in the whole image that I'm having. You focus at that point. Clear? Did that make sense? So the distance or the length at which you focus is going to be called the focal length or focal depth. Clear? Which is going to be the same as your near zone. Because at the end of your near zone is the focal point. At the end of your focal depth is your focal point. And beyond your focus or focal point is going to be the far zone. Any questions? And okay, goes. This thing about your beam is going to come and bite you in your behinds again and again and again and again. At least as long as I'm around. Okay, so it will be repeated again in the next chapter. Then you will come across it in chapter 12 as well. Right? And okay, as at some point, yes, okay, where we are going to stand right next to the machine. Yes, okay, I will say, okay, this is your focal point. Or we can say, okay, your focal length or focal depth. Okay. Now just, well, okay. Take a short break. Let me see. Yes, okay, maybe I should take 20 minutes off. 20 minutes. Yes, okay. And read on the first 3 pages, 29, 30, and 31. Which is mainly as okay with the things that we have talked about so far. Okay, and when we come back to that, as okay, we may as okay just look at okay as diameter of the beam. Okay, and what's the next? Then we have questions. Okay, we can do those together. And okay, it's this general focal depth. Okay, beam divergence and some questions. Okay. Far field. Some questions, and then we have spherical waves and Huygens principle. Good. So see you guys, should I say, at 11:10. Read on the topics, okay, girls? Hey, ladies, welcome back. Any question, girls? No. So we here said, okay, yes, this was a PCT. Yeah, or crystal, or active element. And SSA is okay. And just keep in mind here, okay, as when we look at it, it's mainly going to be as okay like this. Okay. And we mainly can say it's okay if this dimension here. That okay, yes, was, let's say, for instance, 2 centimeter. which means yes, okay, just for me that this here also is okay, be 2 centimeter. Just for an example. That will mainly mean that okay, yes, if we for instance, okay, look at our beam. Okay, where we mean is okay, now say that this here was our near zone. Clear? Okay. Now we can mainly say that okay, yes, the dimension, if we look at the beam here, that's okay, like this. At this level here. Economy says okay that the beam would be it's okay 2 centimeters wide, for instance, and we can say okay also 2 centimeters tall. Is that clear? Now, if you say that this point here is okay was your focus, or what we call the focal point, made up of, let's say, it's okay, this transducer here is okay, where the size of the PCT was 2 centimeters tall, 2 centimeters wide. Where we made okay, that's okay, the main call okay, the initial dimension of the beam also will be 2 centimeters tall and 2 centimeters wide. Clear? The question then comes is okay, if we look at the beam at this point here. Okay, goes is going to be half of the width. So that's going to be okay, we can say it's okay, 1 centimeter wide. And it's going to be half of the height, which may mean that it will be 1 centimeter tall. Did that make sense? Which we mainly could say is okay that at the focal point, the diameter of the beam is going to be equal to half of the beam's diameter, or which in this case, okay, will be the PCT's diameter. When we talk about the beam's diameter, that's going to be okay. It says okay at the beginning point, which will be here. Is that clear? Right. Right. So, as you may see, yes, okay, in the upcoming questions that we'll be talking about, is that okay, yes, this is the diameter of the PCT. Clear, and they may ask, okay, what's the diameter of the beam at the beginning of the near zone? By the beginning of the near zone, they mean it's okay, as the near zone begins. And that's going to be okay, the same as that of the PCT. Where what they mainly will say is okay, what happened is that okay, at the focus, the diameter of the beam is going to be half the size of what it was at the PCT. So say we say okay, it was 2 centimeters tall, sorry, and 2 centimeters wide. Half of that is going to be as okay, the width and the breadth or height, sorry, of the beam at the focus. Did that make sense? Clear? And this whole area here, that was what we call the near zone. Right? Okay. This whole area here is okay, that was what we call the near zone. Whereas this distance here, that was what we call the focal length. Or yes, okay, focal depth. Did you girls get that? Did you girls get that?
Yes.
Yeah.
Okay. Okay. So some of you will say, so why do we say that? Okay, yes, that the PCT, for instance, okay, was 12 centimeters tall and 12 centimeters wide, which may or mean that, okay, at the beginning of the beam, yes, okay, the beam would have been 12 centimeters tall and 12 centimeters wide. Then at the focus is just going to be the half of that would have mainly been that, okay, we're going to be 6 centimeters wide and 6 centimeters tall. Did that make sense? So we mainly can say that, okay, as the diameter of, okay, as the beam is going to be at the focus, is going to be half of the diameter that it was at the source. Is that clear? Did you girls get that?
Can you repeat that? It's going to be half of what?
The diameter of the beam at the focus is going to be equal to half the diameter of the beam at the source. So here is okay if your diameter then was only not 12 or 2 centimeter, we can say it's okay 6 centimeter, which will have mean okay 6 centimeters tall and 6 centimeters wide. Then here is okay, the diameter of the beam will be 3 centimeters tall and 3 centimeters wide. How did we get that? Mainly because, okay, the diameter of the beam at the source or at the level of the source was 6 centimeters. Did that make sense?
All right, so for me, so the diameter of the beam of the focus is half of the beam, I can't say, I'm tongue twisted, of the transducer, the beam of the transducer.
At the beginning,
Okay,
okay, or at the source. Because just look at it here. This is how it goes. This is the source. Clear? Now what happens? Now if you say as okay that the distance from one hand here to one hand, well let's say 8 centimeters. And for the distance from as okay from the top fingers to the bottom fingers also was 6 centimeters. what happens as the beam travels, it narrows down like this. And as we say that, okay, this is the focus. Now our question is, what is diameter of the beam going to be here? It is going to be as okay, half of what it was up here. So if it here was okay as 6 centimeters, at the focus is going to be 3 centimeters. If it was 12 centimeters, it's going to be 6 centimeters. What is 4 centimeters? 2 centimeters. 8 centimeters, 4 centimeters. Did that make sense?
Yes.
Good. Now, what happens to the beam in the far zone? What happens to the beam in the far zone? What happens to the beam in the far zone? Okay, girls. Bye-bye. So my question was just, okay, what do we call, what happens to the beam in the far zone? Yes.
It
Is
gets
there
like,
anybody who knows what? Yeah,
I said it gets wider.
it gets wider. Good. Okay. Okay. So it gets wider. Or that can also be referred to that it diverges. Did that make sense?
Yes.
Clear? Now, just in this instance here, because practically as okay, it is going to be as okay a little bit different. But if we said, okay, yes, if this distance here is okay, or the focal depth or focal length, we can check any distance, it doesn't really matter. We can say it's okay to be focused at a depth of, let's say, 4 centimeters. Okay, which may mean that, okay, as our near zone was also going to be 4 centimeters. The question then just goes as, okay, or the question then is, what would be the diameter of the beam? At this point here, we say it's okay that this was okay, let's say it's okay, the end of our far zone, right? Okay. Okay, but how far? If we say that, okay, that this distance here from the focus to the end of far zone, yes, okay, also was 4 centimeters. Okay, now just yes, okay. Get rid of all this confusion here. We can mean it says, okay, let's just go back and says, okay, that we have a whatever width or depth or width or breadth of our beam. Okay, and PCT. We can say as okay, if our PCT, for instance, as okay, was 2 centimeters high. And likewise, that's okay, 2 centimeters wide. That mainly mean that, okay, yes, at the, at the focus, our beam was going to be as okay 1 centimeter wide and 1 centimeter high. Clear? Just half of what we had at the source. Did that make sense? And we, for instance, in this case here said that okay, as our focal depth was 4 centimeters, mainly mean that okay, the distance between the source and the focal point was 4 centimeters. Clear? And we just were going to say, that's okay, what is going to be as okay, the diameter of our beam at this point here. How wide is it that it's going to be? How tall is it that it is going to be? Now, since here we say okay, at a distance of 4 centimeters from the focal point, that means that at this distance from the focus or focal point to the point that we refer to as the end of our bar zone is also 4 centimeters. Then, okay, yes, it is going to be back to being as okay, 2 centimeters wide and 2 centimeters tall.
A question.
Yeah.
Where's the 2 centimeters tall and wide is coming from?
Mainly because that was the size of your PCG.
Okay.
Right, okay. Okay. But here is okay, in this instance, yes, okay, goes what we mean is okay, just says okay, we have a circular PCG. Okay, now as we go on to later chapters, you will actually see that okay, as the shape and the measurements of the PCG is going to change. But again, yes, okay, the concept is still going to be the same. Because I will say, okay, this was the size of your PCG. It produces a beam that is going to be as okay, this tall and this wide. Now, how tall and how wide is it that it will be at the beam is going to be at the point of a focus? Half the height, half the width of the PCG. Or practically as okay, I'm sorry, half the width of the beam at the source and half the height of the beam at the source. That's going to be as okay, the dimensions of your beam at the focus. Did that make sense? Okay, so these says, okay, this 2 centimeters high and 2 centimeters wide. This is just any random number. Okay, if we could change it to any depth, or we could change it to any size, you could say as okay, if it was, let's say as okay, 3 centimeters and 3 centimeters. But then the thing here was that okay, as the size of the beam at the focus was just going to be half of 3, which is going to be as okay, 1.5, which mainly will mean that okay, as the beam would have been 1.5 centimeter wide, and it will be as okay, 1.5 centimeter tall. Did that make sense?
Yes, so I have another question.
Go ahead.
So whatever the diameter is from the PZT, it's going to go halfway to the focus point, and then it's going to, when it goes to the near, no, not the near, the far zone is going to go back to the original, which was 3 centimeters. It's going to go half.
Exactly.
Okay.
But that's only going to be the case if we say that, okay, yes, that, okay, as our focal depth was 4 centimeters. So 4 centimeters beyond the focal point is going to go back. If you go further, and you say, okay, I go further than 4 centimeters, let's say it's okay, I go to a depth of 6 centimeters from the focal point, that you can mainly see as, okay, the beam diverges even further, right? Okay, so we can mainly say, okay, we may not be able to exactly say how big it is, but if it was, okay, as 3 centimeters and 3 centimeters at a distance which was 4 centimeters off the focal point, because your focal point was at a depth of 4 centimeters.
Mhm.
If you go further into the far zone and say 6 centimeters off the focal point, then you can maybe say that the beam actually has become bigger than it might have gone from 3 centimeters to, let's say it's okay, become 3.5 centimeters tall, or 3.5 centimeters wide. This is just going to be an estimate. Right, okay, because just look at it. This was the width of the beam at the source. Clear? Okay, let's just stay with the width. But you can say, it's okay, the same happens to in the height. Did that make sense? Right, okay. So it goes like this. Your beam goes like this. What will happen? It becomes narrower, right? Okay. Now let's just say that, okay, the distance between is, okay, the source here and focus was 1 foot. What happens then? The beam travels further beyond the focus. And what that's got called? That's the far zone. That's where the beam is going to diverge. For the first foot, yes, okay, may diverge out and become, yes, okay. Again, yes, okay, 8 centimeters wide. Whereas, okay, as if it converges, okay, if it travels further and further, it's going to diverge more and more and more and more. Did that make sense? Okay. Okay. So this here, we can mean it says, okay, that is going to be, yes, okay, if it was 3 centimeters here, it's going to, yes, okay, be 1.5 centimeter wide, 1.5 centimeter tall at the focus. Okay, which we said, okay, as what a distance of, let's say, okay, 4 centimeter. Another 4 centimeter from the focus. What's going to happen is that the beam is actually, okay, going to diverge back into a width of being, that's okay, 3 centimeters tall and 3 centimeters wide, at a distance of 4 centimeters from the focal point. But if you go further into the far zone, what's going to happen? The beam is going to, okay, keep on diverging. So that's okay, the distance from side to side, which will be the width, will also increase. The distance from the top to the bottom, which is going to be the height of the beam, will also keep on increasing. Did that make sense?
Yes.
Yeah. Okay. Oh, yes, okay, what we can do. No, it's pretty much okay, yes, the same. 4, okay, 4, 8, and 12. Okay, the same diagram. Okay. The same diagram. Now, please, girls, keep in mind that here is okay, talk about, yes, okay, a disc-shaped PCT. Okay. or yes, okay, as we may call round. Okay. Now, practically, yes, okay, for most of your transducers, PCTs, they're going to be like this. Where you actually, yes, okay, we'll see that, okay, yes, they have different depths, different widths and different heights. Okay. But then we also, yes, okay, we'll see that it's going to be, yes, okay, multiple PCTs like this, lined up side by side. But right now, it's okay, don't get into that. So for this here, it's okay, it's mainly, it's okay, just a question of saying, if this is just okay, your disc-shaped PCT, you can mainly say, okay, from side to side, that's going to be as okay, the diameter, also you can say the width of the PCT. Clear? That will mainly as okay determine how wide the beam is at the source. Right? Let's assume that my face is okay is around PCT. Then this is going to be as okay the width of the beam that I produce at the source. Did that make sense? Whereas, okay, now since it is what we call as okay disc shaped, or pretty much okay as a round, we can then just say as okay refer to this dimension here. Let's just use another color. It has a contrast, which is going to be as okay is the height of the PCT. And what is that going to determine? That's just going to determine as okay how tall, or if you want to call it okay high, the beam is at the source. Did that make sense? So at the focus, this is then going to be your beam. Where we mainly can say, okay, that the beam in this case is going to have okay, a height, which is half of the height of the beam at the source. And so for the width. Now let's see. Okay, so this is going to be as okay the width. And what is that going to be? Okay, that's going to be half of the beam's width at the source. Did you get that? So if here we can say, okay, if it was 2 centimeters wide, and let's say it's okay 2 centimeters height, then okay, half of that is going to be as okay the height of the beam, and half of the width is going of the beam at the source is going to be as okay the width of the beam at the focus. Because what happened what actually caused it to go from this big diameter to this smaller diameter here was what the beam underwent in the near zone. That it actually is okay, narrows down or converges. The opposite just happens in the far zone. Did that make sense? So for this conference, okay, for this part here, we mean it says, okay, the degree at which it converges in the near zone is going to converge at the same degree in the far zone. So if I go like this, I go like this. Practically go, but that's later on. It's going to just, okay, you will have lesser convergence, but as the beam goes into the far zone, it's going to be a very, as okay, acute, or as okay, certain divergence of the beam. Okay, so let us just look at page 133 and 134, and it's the same diagram. Or we can actually say, okay, it's the pretty similar beam. Well, that's okay, or diagram that we will use. So we say, okay, this is your PCT. Or we can say, okay, this is your transducer. Okay, they mainly is okay. Now let me just see if I can somehow reproduce this thing here. So this here is okay, that is your disc-shaped PCT. And what they mainly say is that, okay, as the dimension from here to here is 12 millimeters. Did that make sense? Then they go on and, okay, let's make your beam. Now I'm just going to just, okay, use a little bit different colors. If you can say, it's okay, this here is okay, that is your near zone. Clear? Where we actually is okay, we can say, it's okay, that will reaches the focus here. And what they mainly say is, okay, at this distance here is 8 centimeters. Then we have, yes, okay, our far zone. Right? Right. And then here is okay, you actually is okay, this up here, which they say is 4 centimeters. That actually is okay, represents the focal zone. Clear? Okay, but for the next 8 questions, not 8, sorry, 10 questions, this is just okay, the diagram that we actually just okay will be looking at or referring to. Our goals now, just look at the first question. Okay, so the first question reads, what is the best estimate of the diameter or width of the sound beam as it exists or exits the transducer? Or the main is okay, we'll say it's okay, if we look at the beam at this point here, where is going to be as okay its diameter, or we can say it's okay, either the width and or height. Now that's why I say it's okay if your PCT is 12 millimeters in this case here. That may mean that okay, it was going to be as okay 12 millimeters tall. And okay, since it is a disc shaped transducer, it's also going to be 12 millimeters wide. So the main is okay, just ask us, okay, what's going to be the diameter of the beam or width of the beam as it exits the transducer, or right at the beginning of the near zone. Here, so you have 6 centimeters, 6 millimeters, 9 millimeters, 12 millimeters, and 8 millimeters. And as I just said, right at the beginning, the diameter of the beam is going to be the same as the diameter of the PCTs. Right? Because they haven't converged yet, or it hadn't started to narrow yet. Did that make sense? So that's okay. The answer for that one is going to be the same as that of the PCT, which will be 12 millimeters. Now just keep in mind, girls, 12 millimeters is going to be the same as 1.2 centimeter. Is that clear? Now question number 2. Question number 2 mainly is okay, just ask us, yes, okay, what is the diameter of the sound beam at a depth of 8 centimeters? This here is at a depth of 8 centimeters. And what did we have at a depth of 8 centimeters? That was actually, it's okay, where we had our focus or focal point. And what did we just say? That the diameter of the beam at this point here is going to be half of what it was at the beginning. But the main is okay, it's just asking us, okay, then what is the half of 12 millimeters? How many meters? Okay, so at this point here, it's okay, the beam would have been 6 millimeters wide and or 6 millimeters tall. Right, okay. Did that make sense?
Yes.
Yeah. So yes, okay. 6 millimeters. What was, where did we get that from? Meaning that's okay, because that was okay as half of the diameter of the beam at source, which we answered in the previous question that it was going to be the same as that of your size of the PCT. Did that make sense?
Yes.
Good. Question number 3. Now, what they made is, okay, says, okay, then what is the diameter of the beam at a depth of 16 centimeters? Now, at a depth of 16 centimeters, that mainly as okay mean from here. So we can say, okay, this was 8 centimeters, and then you just have another 8 centimeters. And I just mentioned it before that here is okay. Theoretically, now we can mean it says okay that the beam is going to go back to a diameter of being 12 millimeters wide, and or yes, okay, 12 millimeters tall. Okay. Because that's okay, this 16, yes, okay, total 16 centimeters here is, you can say it's okay, twice your focal depth. That is made as okay, just going to be the same diameter as it was at the beginning. Because for the first, well, that's okay, for the focal depth, it converges, it narrows down to half. The equivalent on the other side of the far zone, it means as okay, diverges out. So it's going to come back to yes, okay, being 12 millimeters wide or tall. Did that make sense?
Yes.
Good. The next question just ask, 4 is asking, at what depth is the focus? Because, okay, from the source to the focal point, yes, okay, the distance was 8 centimeters. So this was your focal point or focal depth. So at what depth or at what point is the focus? Is going to be as okay at 8 centimeters. Did that make sense?
Yes.
Good. Anybody who didn't get it? Now, question number 5. And the mainly says, okay, what depth? Now just keep going, just keep in mind, yes, okay, goes as we go from here to here, all the way, it's okay, it is horizontal, but we actually can say, okay, that this is going to be, it's okay, and increasing depth, mainly as okay on an image, yes, okay, it might be, that's okay, like this. Clear? Okay. So what they mainly say is that, okay, at what depth is the beginning of your near zone? Oh, sorry, focal zone. Now look here, girls. This line here is, okay, I said that marks the focal zone. And they say that, okay, as the focal zone is 4 centimeters. Now earlier, as okay, when we talked about focal zone, what did I say? Half a focal zone. Is in near zone. And we can say, okay, the other half of focal zone is in far zone. So what is going to be half of your 4 centimeters here is going to be 2 centimeters. Fall into the near zone. 2 centimeters, just okay, falls into the far zone. Clear? There, okay, yes, you may says okay. The focus or focal point, yes, okay, that was the center of your focal zone. So the main is okay, just asking you is okay, at what point, what depth is it that just okay, your focal zone starts? If it was 4 centimeters and your focal depth was 8 centimeters, it's going to be 2 centimeters. So you can say this would have been a depth of 6, 7 centimeters. This would then become as okay, a depth of 6 centimeters. So it's okay, your focal zone is going to start at a depth of 6 centimeters.
How will we be able to identify that based on the question?
It's written. What depth marks the beginning of your focal zone? This is your beginning of the focal zone. And they may, yes, okay, just ask you what depth marks the beginning of the focal zone. Now you have a focal depth of 8 centimeters. Your focal zone as a total was 4 centimeters. But what did I say? Half of your focal zone falls into the near zone, the other half falls into the far zone. So you actually have, you actually have to answer all these questions here, looking at the diagram 9.4, which I somehow try to reproduce here. Did that make sense? If you haven't been given any of these numbers here, yes, okay, you would not be able to say, yes, okay, where the focal zone because begins. So all these questions here, yes, okay, are answered using, yes, okay, a reference to diagram 9.4. Did that make sense?
Yes. So it will always be less than, because it's narrowing down, going to the focal point. So it has to be less than the 8 centimeters.
Yes,
All right.
because it falls into the near zone, right? The end of your near zone is the end of your focal length. Or we can say, okay, the end of your near zone is marked by, yes, okay, the distance of your focus. Clear? Okay. Or your focal point. At the point or at the distance from the source at which the beam focuses is called the focal length. Or depth. The depth at which your beam focuses is called the focal depth. Did that make sense? But if you say, as okay, at 8 centimeters, yes, okay, that's where the beam focuses. But then we say, as okay, now around the focus or focal point, do we have an area that we call the focal zone? Now in this case, it's okay, your focal zone was 4 centimeters. Okay, but where we say where the concept of focal zone was that okay, as whatever size it was, half of it falls into the near zone, half falls into the far zone. So if you say, okay, what's going to be the beginning point of your focal zone? That's just going to be as okay, half of your focal zone's distance into the near zone. Now here since that's okay, your near zone was okay, 8 centimeters. Which is maybe as okay, the focal depth as well. That's going to be as okay, the 2 centimeters, which was half of your focal zone, into the near zone is going to be at a depth of 6 centimeters. So that's going to be the depth at which the focal zone would start. Did that make sense?
Yes.
Good. Question number 6. Which means, okay, just now ask the opposite. What depth marks the end of the focal zone? Now you can say it's okay, the end of the focal, yes, okay, the end of the focus was your focal point, which was at a depth of 8 centimeters. Your focal zone at shoulder was 4 centimeters. Okay, which half of it falls into the bar zone, and that's going to, yes, okay, and mark the ending point, end of your focal zone. So you can say, yes, okay, these 8 centimeters, another centimeter, and another centimeter. So 8 plus 1 is 9, plus 1 is 10. So it's going to, yes, okay, end at a depth of 10 centimeters. That's what marks the end of your focal zone. Did that make sense?
Yes.
Good. Question number 7. At which of the following depths is the beam narrowing? Now, they are given at different depths: 6 centimeters, 8 centimeters, 12 centimeters, 10 centimeters, 9 centimeters. But what they are asking us is, at which of the following depth is the beam narrowing? Okay, and the only one that, okay, yes, makes sense here is at a depth of 6 centimeters. If you mean, yes, okay, said was here. Because what happens beyond this point here is, okay, the beam is still narrowing. At 8 centimeters goes, that's okay, your beam was at its narrowest. Okay, and what happens at, okay, at things such as 9 centimeters, 10 centimeters, and 12 centimeters? That's where the beam is widening. So yes, okay, at a depth of 6 centimeters, yes, okay, that's the depth at which, yes, okay, of the list given, where the beam, yes, okay, still was narrowing. They could have said, okay, at a depth of, let's say, 1 centimeter, for instance. That's okay. If that was the case, well, okay, it would still be narrowing. But from the numbers given here, it's okay, depth of 6 centimeters. That was a point at which the beyond which this beam still was narrowing. Or we can say it's okay, getting narrower.
Question.
Yeah,
So the focal point is 8.
it's at a depth of 8 centimeters.
Yeah, okay, so, and then after it leaves the focal point, it goes from 9 and 10, and it starts to increase, like the number increases. because
Exactly.
of-
Then the beam is widening out, right?
I think I got confused because when we divided the 12 millimeters, I already thought the focal point was 6, but apparently not.
It is 6 millimeters, but that's not what it's asking you.
Okay.
That was the diameter of the beam.
All
Now,
right,
how wide and tall the beam was.
and not how far it is.
No,
Got it. That's something I was getting confused from. Okay.
you just have to look into it, look. And which are the fallen depths? What is this? As we go here, we're going deeper and deeper and deeper, right? That's what I said down here. So which are the following depths? Now they're giving you just, okay, different depths. Is the beam still narrowing? So it says, okay, we have a depth of 6 centimeters. We have a depth of 8 centimeters. They said, okay, 9 centimeters, 10 centimeters, and let's say it's okay, 12 centimeters. So which of these depths here is the beam still narrowing at a depth of 6 centimeters? Because at this point, it's okay, as it travels, it still keeps on narrowing down. Did that make sense?
Yes.
Good. Question 8. At which of the following depths is the beam widening? Right, okay, so here's, okay, they just ask about the completely different, or the complete opposite. Clear, and then they have, okay, as 2 centimeters, which could have been here. Okay, we have 4 centimeters, which could have been here. Then they go as, okay, with the 6 centimeters, then they go with 8 centimeters, then they go with, okay, as an odd number, which is 9.375 centimeters. Okay, which maybe is, okay, somewhere here. And it says, okay, which of the following point is the beam still narrowing or still widening? It's going to be from here. So that's why, okay, that odd number 3.75 centimeters. Because from that point and onwards, that's okay, the beam is still widening. Did that make sense?
Yeah.
Good. Question number 9. Now, which of the following beam, at which of the following depths? So they are giving you different depths. Which means, okay, as we go from here to, it's okay, here. Like this. Right, okay. Is the beam most likely going to be at the same diameter as it has at the depth of 11 centimeters? Which would have been here. If this is 11 centimeters, which we mainly can say as, okay, is, that's going to be as, okay, the cheat that we will use. One centimeter after end of focal zone. Because, okay, what is the diameter of the beam at a distance 1 centimeter behind or after the end of the focal zone? Just in a different way, which is 11 centimeters. Clear? So they are giving us different depths, and this says, okay, 1 centimeter, 3 centimeter, 5 centimeter, 8 centimeters, and 14 centimeters. And the answer is going to be 5 centimeters, which is, again, it's okay, 1 centimeter prior to the beginning of the focal zone. Because at 6 centimeters and 10 centimeters, that's okay, the beam was going to have the same diameter. But here's okay, they went 1 centimeter into the far zone. And say, okay, what's going to be as, okay, another area of the beam or another depth at which the beam is going to have is, okay, this estimated same diameter as it has at this depth here. Then that's going to be as, okay, at this depth. Right. Why? Because it's okay, we made it. So at least in this instance here, see even convergence and an even divergence of the beam. Did that make sense?
Yes.
Right, okay. Because what we mean is, okay, you can still say it's okay, the focus area is going to be half of what it was here. So had they said, for instance, not 11 centimeters, but had they said, let's say it's okay, 12 centimeters. Then what's going to have been 4 centimeters. Had they said 13, then just 2, and so on. Did that make sense? Watch the number 10. So here's okay, the answer is going to be as okay at a depth of 5 centimeters. Question number 10. Now, which of the following terms does not belong? So that means it's okay, going to be a term here which doesn't mean the same as the other, or we can say it's okay, represent the same area of our beam, yes, okay, here as the others. Now, one is what we call focus. Now, we already said this here is okay, was your focus. Clear? The other says end of near zone. Well, okay, this is your end of near zone. Did that make sense? So that's the yes, okay, marks the yes, okay, the point of focus. Did that make sense? Now, if you go to the next one, which says end of Fraunhofer zone. Now, you have to know what the Fraunhofer zone is. Because your Fraunhofer zone was mean it's okay, just another name for the far zone. And if you see it's okay, the end of far zone or Fraunhofer zone is going to be here. That's not the one. But just look at the last one, the middle of focal zone. Now this was your focal zone. And we say it's okay, the middle of your focal zone is again, is okay, your focal point of focus. So the only one that didn't, yes, okay, match the other terms was end of Fraunhofer zone. Okay, there again, as I said, you gotta know that, okay, as Fraunhofer zone is just another name for your far zone or far field. Clear? If you didn't know that, then you might have said, okay, well, okay. That's okay, I have 3 zones. That's probably going to be the one that's going to focus. This is, you know, whatever way you have to look at it. Because you didn't know, yes, okay, what the Fraunhofer zone was. Or as a matter of fact, you might not know, yes, okay, what the focal zone was. So end of far zone, well, okay, that is not. It would have been a different case had it said beginning of Fraunhofer zone. Then that would also have been your focus. Because, okay, if you look at your far zone, if this is your far zone, and I say beginning of far zone or beginning of Fraunhofer zone, that will still be your focus. So all terms here is okay, A was focus, but then I say, okay, middle of, it's okay, end of near zone is also going to be focus. Because there's okay, middle of focal zone is also going to be the focus. Okay, the end of Fraunhofer zone or far zone is not going to be your focus. And it said beginning of Fraunhofer zone or far zone, that will also have been your focus. Yeah, or I could say as okay, the point where the beam is at its narrowest. That could still belong as okay, still could be referring to the focus. It could have said focal point. That would still have been your focus. It could have said, okay, end of focal depth. That would still have been your focus. Okay. Did you girls get that? Or for the one that says, okay, end of near zone, I could have said end of Fresnel zone. Now, if you don't know what the Fresnel zone is, then okay, you will be lost again. Is that clear?
Yes.
Good. Any questions? Any questions, girls?
No.
Good. Now just take a short lunch break. Okay. And when we come back, what I actually as okay, I'm going to do is mainly as okay, summarize down your next 5-6 pages down to 1 page. Oh yes, okay, you can make, okay, yes, you should have a piece of paper or something that you can use as an index card to, yes, okay, post on your closet wall, dressing mirror, refrigerator, or something to look at. Okay, because we're going to just, okay, talk about some relationships which are going to be, we can say it's okay, important. Clear? Okay, so I see you girls, should we say 1:15? Is that fair?
All right.
Okay. Okay, girls, welcome back. Now, any questions? You girls are good on focus, focal point, focal zone, focal depth, near zone, Fresnel zone, far zone, Fraunhofer zone. Okay, girls. Um, Now, girls, the kind of, it's okay, what we can say is okay, translucent that we will talk, I have been talking about is what we can call as okay, a fixed focusing. Transducer, which mainly mean that it only have one, and that's going to be fixed focal point. Clear? And when we say that something is fixed, What that mean? That would mean that, okay, yes, it would not be adjustable. And something was not adjustable, I mean, it's okay, because it's okay due to the makeup or it's okay manufacturing of the transducer. Okay. Now, although you can say it's okay that nowadays transducers are what we can call as okay multifocal, which mainly mean that okay, as they are having, are we actually able to adjust the focus at, because it's okay multiple focal points if you want to. And not only is that going to be as okay multiple, but we can actually as okay move them down to greater depths or move them up to shallower depths. Where we say it's okay, a fixed focus transducer, that was mainly going to say be that okay, as we had a transducer, and okay, as that was going to focus at a fixed focal point, which was, when you said not fixed, that is going to be as okay, that is not changeable. Okay, and when we say not changeable, that means that okay, as we can't move it up, we can't move it down. Okay. Did that make sense? So for those things now, girls, and that's why I says okay, mainly as okay, the next common pages, which is mainly as okay about two things that we're going to look at, is how did we determine, or we first can call as okay focal depth. Where, how did they determine focal depth? Now, please, girls, if there's anybody who still didn't understood what focal depth meant, speak up now.
Can you explain it?
Well, we can say, okay, that's going to be the depth at which the beam will focus. What did we mean to focus? Or a beam focusing? That is, we can say, okay, beam is at its narrowest diameter, right? Did that make sense?
Yes.
Right, okay. And if you look at, okay, yes, your focal point or focal depth, we can mean it says, okay, this is also going to be as okay, somehow as okay related to as okay what we call the near zone. Okay. Now based on this, we can mean it says okay that there are going to be as okay two factors that will determine the focal depth. One is going to be as okay what they as okay, what your book main is okay, say diameter. Okay, not really as okay accurate. It's going to be as okay more accurate as okay. We can say it's okay the diameter of the Where were we? Okay, sorry. Of the PCT. The second is going to be as okay frequency. Okay, we can make it as okay, we get the frequency of the sound of transducer. So what we mainly can say here is okay that your focal depth. Now, please keep in mind, go that this word is okay when we talked about transducers which had a fixed focal depth, which mainly means that okay, yes, it is not adjustable. Okay, it is not adjustable, it is fixed. So what factors was going to yes, okay, determine the point at which yes, okay, the or the distance at which yes, okay, the beam would diverge to its narrowest, because if we say that this here is the focus, then mean yes, okay, this distance here would be the focal depth. Now there are going to be as okay two things. One which will remain is okay will be as okay the diameter of the PCT. How big or small is it that the PCT was? The second was going to be as okay, what was going to be as okay the frequency of this transducer. Okay, so pretty much okay as what the next couple of pages mainly is okay just talk about is how is it that okay as focal depth is related to the diameter of the PCT and the frequency. But the main thing that you guys just need to remember is okay as what this relationship here is. So we can make this okay, that's going to be as okay directly proportional for both of them. Now, when we say it's okay, directly proportional, what that means will mean that okay, as the greater the diameter of the PCT, mainly will cause that beam will focus at a greater depth, which mainly will mean that okay, there will be a greater distance between the transducer and the point at which it focused. Whereas if you went the other way and say, it's okay, focus at a shallower depth, if the PCT had a smaller diameter. And all the same will also apply to the frequency. Now, girls, please keep in mind, we are not talking PRF. We are talking frequency. Okay, so if the transducer is okay had a greater frequency, that will mainly mean that okay, as it will focus at a greater depth. Which mainly means that okay, the beam would have diverged to its narrowest point at a greater depth, and vice versa. So you would have had a shallower focal depth if the transducer had a lower frequency. Did you girls get that? So here we can mainly say as okay that your focal depth or the focal depth, the depth at which the beam, yes, okay, will focus. What does it mean for the beam to focus? That mainly means that, okay, the beam reaches its narrowest diameter. Okay, but that was going to be, yes, okay, determined by two factors. One was the diameter of the PCT. What did we mean by the diameter of the PCT? Because yes, okay, the PCT either had, okay, as a big diameter, which means, okay, that's a big PCT. And or on the other hand, because yes, okay, the PCT might have had a small diameter. Clear? Okay. So the diameter of the PCT was going to be, as okay, be directly proportional to the focal depth, which mainly means, okay, great focal depth, or mainly mean, okay, the beam will focus at a great depth. Whereas, okay, as if it had was a small PCT, yes, okay, that beam would have focused at a shallower depth. Did that make sense? Did that make sense?
Yeah.
Good. The next thing that we could say is, okay, again, what could be another factor that, okay, as would have caused the beam to, yes, okay, either focus at shallow depths or great depth was going to be, as okay, the frequency of the transducer. So if you had a frequency, or if you had a transducer with a greater frequency, let's just say, yes, okay, for instance, okay, 6 megahertz. That will have a greater focal depth compared to, yes, okay, a transducer with a lower frequency, let's say, yes, okay, 3 megahertz. Yep. So the relationship between focal depth and diameter of the frequency, or diameter of the PCT, and frequency of the transducer was directly proportional, which mainly means when either of these two factors here or both increases, that will increase the focal depth, whereas either or both of these two factors here decreases, that will cause us, okay, a lesser focal depth. Did you girls get that? And in the whole course of the beam, yes, okay, what actually is okay is going to, yes, okay, determine the focal depth, that's going to be, yes, okay, the near zone. So as we just said earlier, a greater focal depth actually means that we have a greater near zone. Where, okay, as a smaller focal depth or a shallower focal depth actually means that we had a shallower near zone or smaller near zone. Right? Because we said great focal depth would be, yes, okay, the focus is there, okay, this is a depth here. What we call that, okay, as either, yes, okay, a great PCT and or, yes, okay, a high frequency. What that means is, okay, it just leads to a great focal depth of focal length. Whereas, okay, as on the other hand, if we said a small PCT, and or yes, okay, a small lower frequency will cause this beam here, okay, to focus at a shallower focal length or at a shallower depth, which will mean that okay, we will have a lesser focal depth. Because here we can say, okay, if this distance here is okay, was this was at a depth of, let's say, 8 centimeters, that there could have been, okay, at a distance of 4 centimeter, for instance. Did that make sense? Did you girls get that?
Yes.
So this was just okay, part number 1. Okay, so focal depth is directly proportional to what? Diameter of PCT and frequency of transducer. Okay. And okay, what mean is okay, determine just okay your focal depth, or was okay as part of the beam. Right, which was going to yes, okay, be you can say it's okay, directly related to yes, okay, the what the hell you call that fellow? Focal depth was okay, yes, you were. Yes. Okay. Any questions? Any questions?
No.
Good. Now you may look at page 137 and you may see, yes, okay, some equations there, right? You guys have your books? So
Yes.
page 37, well, okay, those two horrible equations. Hakuna Matata. Don't worry about them, okay?
Okay.
Okay, so mainly it's okay, just this relationship here is okay. If you got that, you should be good. But please keep in mind, goal, this is for fixed focal depth transducers. Or as we as okay later on will call them mechanical transducers. Is that clear?
Yes.
Good. The next thing that we made as okay, can just talk about, and again as okay, is going to be as okay. What is going to determine as okay the beam divergence? Now goals. Is there anybody who has any doubt about what divergence means?
I do.
Why?
Because I can't think of what's the definition offhand.
There is no my dear, it's a word.
Oh, I'm sorry. I thought it was like what it means in a book. I'm sorry. Okay.
Or what does the word divergence mean? It means it's okay, it comes from that word. Spreading out. Or we can, in this case, is okay, say broadening. Broadening of what? Of the beam, right? And where does this occur? Where is it that the beam diverges? Or actually broadens out? Or because yes, okay, will become wider.
The far zone.
Far zone. Okay. So again, go, that's okay. This is again going to be, that's okay, determined by the same two factors as we had for the focal depth. Which was, because it's okay, the diameter of PCT. And again, it's okay, frequency of the transducer. Clear? But now comes the question, yes, okay, how is it that, okay, now since they are related, that's mainly going to mean that, okay, as the diameter of the PCT is going to, yes, okay, determine or have an effect on how much the beam is going to diverge. Where is that diverging happening? In the far zone. Likewise, okay, the frequency of your transducer is going to have an effect of how much the beam diverges. Where does that occur? In the far zone. Clear? So here, ladies, that's okay. The relationship between beam divergence which may mean the beam going out like this or diverging. And the PCT diameter, which was okay at the size of the PCT. And likewise, okay, you can say, okay, frequency of sound or frequency of the transducer also is okay, had a relationship to, yes, okay, there. Divergence of the beam. But here, as okay goes, that relationship for both of them are going to be inversely related. Which mainly is okay, now since it is inversely related, that will mainly mean that a PCT with a greater diameter actually is okay will lead to, yes, okay, a lesser divergence of the beam. And where does this divergence of the beam happen? In the far zone. Whereas if we said, yes, okay, we had a small PCT, which means that it will be a smaller diameter, that would actually lead to, yes, okay, greater divergence of a beam in the far zone. And we can say the same for the frequency that, okay, yes, if and or the frequency was less, that one can, yes, okay, lead to, yes, okay, a greater divergence of this beam in the far zone, whereas, okay, we had a greater frequency transducer. That will actually lead to, yes, okay, lesser divergence of the beam in the far zone. Okay. So here is, okay, the relationship to the same two factors that we had for, as, okay, focal depth are going to, yes, okay, be inversely related. Clear? So if you said, okay, yes, now just yes, okay, we said, okay, yes, we had this frequency as, okay, will be as, okay, the focal point, because the main thing that we are going to is, okay, talk about is, okay, what happens beyond the focal point. That's going to be as, okay, that the beam diverges. Right, okay. Now this degree of divergence here is going to be as, okay, inversely proportional to the diameter of the PCT. So we can mainly say as, okay, that if we had a transducer with a great PCT size, a great PCT diameter, we can say as, okay, right now we just say, okay, if this was the focal point, right, okay. What is it that we said? That beam is going to, okay, have a lesser divergence in the far zone. And what did that lesser divergence mean? That will mainly mean that, okay, yes, it's going to diverge just like this. So what is that we actually see here? That, okay, as we can say, okay, that the beam, because it's, okay, remains narrow for a greater distance into the far zone. But that is also as, okay, if and or as, okay, we had a great frequency where we could say, okay, again, as, okay, because let's take any great number. We can say, okay, let's say 8 megahertz. So either of these two or both, mainly as, okay, we'll call that, okay, in the far zone, as, okay, the beam would diverge. That's okay, there'll be as a lesser divergence. Whereas, okay, we take, okay, as said, while we had a small PCT. And or as, okay, because as, okay, low frequency, let's just say as, okay, here, we just say as, okay, a frequency of 4 megahertz. Either of these, the small side PCT or small size PCT, and or yes, okay, with the lower frequency, mainly will cause that, okay, as both of them is okay, lead to yes, okay, increased divergence of the beam. And what would that mean? That would mainly mean that, okay, if this was our focal point, clear? Okay, and all this over here is going to be it's okay, far zone, that the beam actually is okay, would diverge like this. Did that make sense?
Question.
Yeah.
So for a lower frequency and a smaller diameter of the PCC, will those two match? So the smaller the diameter is, the lower the frequency?
No, these are just two factors. And that's why I say either or both. Because you can again say, okay, what if we had two PCTs of the same size? Let's say it's okay, two small PCTs, right? Okay, they are of the same size. Let's say it's okay, 2 centimeters in diameter. But then it's okay if they had, let's say it's okay, different frequencies. One had a frequency of, let's say, 4 megahertz. Other one had a frequency of, let's say, it's okay, 2 megahertz. Now they may ask, okay, which of these two here will have, yes, okay, the greatest divergence? It's going to be this one here.
Okay.
Why? Because of the lower frequency. What would that greater divergence mean? That the beam is going to say, okay, diverge like this. Where here is okay, you can say, oh no, yes, okay, they were same size PCTs, but just because this here had a higher frequency that it actually lead to have, okay, yes, because there's okay, a lesser divergence. Did that make sense?
Yes.
Okay. So you can already see, yes, okay, what kind of questions, yes, okay, may pop up. Similar questions that we had for stiffness and density related to speed. Right, okay. Thickness of PCT and okay, yes, propagation speed in PCT related to frequency of transducers, right? Did that make sense? Okay, so here goes what we mainly say is the greater the diameter of your PCT, lesser will be the degree of divergence, which mainly means, okay, if this was the focal point, and you says, okay, lesser divergence is going to just, okay, let's go like this. Whereas if you say, it's okay, greater divergence, now what's going to cause that greater divergence? Smaller PCT, like this. Clear? Likewise, okay, yes, that lower frequency of the transducer may actually cause the beam to diverge more compared to, yes, okay, if it was a high frequency transducer, that's going to, yes, okay, be lesser divergence. So yes, okay, if there's a lesser divergence, what actually happens is the beam, yes, okay, may, yes, okay, maintain a relatively narrower diameter for a greater depth than if a beam diverges out like this. Clear? What was the two factor was going to cause the beam to diverge out like this? Low frequency or small size PCT. Okay. Okay. And this lesser degree of divergence of the beam is going to become, yes, okay, important in the next chapter. Okay, I know your book already is okay in this text is okay, still already is actually not talking about is okay, lateral resolution and all that. But don't get into that yet. Clear? Okay, but just remember, the wider the beam, poorer lateral resolution. Narrower the beam, better lateral resolution. Clear? Okay. Any questions? But you can mainly says, okay, those, that's okay, a couple of pages from, yes, okay. Page 135 to 140. So approximately as okay, some 5 pages. And be summarized down to this, there we say focal depth is directly proportional to diameter of PCT and is directly proportional to the frequency of the transducer. What does it mean to be directly proportional? If this increases, or this is increases if either or both of these increases, this will decrease if either or both of these decreases. Okay, what was okay as a factor that okay as was related to is okay your focal depth. That okay is in the near zone of the beam. Whereas okay, as on the other hand, we can say beam divergence. Now, beam divergence, my dear girls, is going to okay again be because that's okay related to the very same things that we had up here. But here it's okay, it's going to be inversely related. So you can mean it's okay, it's going to be inversely related to the diameter of PCT or crystal or active element, as we may call it, and or frequency of the transducer. So what does it mean to be inversely proportional? That if this here increases, that's because either of these two here or both are low frequency or small PCT, and or vice versa. That okay, as the divergence of V may be low if the size of the PCT is big or the frequency of the transducer is high. Okay, so in a beam, will be as okay at great focal depth. Will be a shallow focal depth. In a beam, yes, okay. We can say, okay, will be as okay a great and less beam divergence. We can just say, look, as if this here was our focal point, then a great divergence was going to be a lesser divergence was going to be something like this. Did you girls get that?
Yes.
Right, okay, back dear girls. So that's how you made this, okay. As I said, summarize one page, okay, or 5 pages down to 1. Okay, and that was pretty much okay as all that you needed to to know. But please keep in mind, girls, this only applies to, yes, okay, what we call fixed focused transducer. Clear? Okay. The transducers that we have nowadays, that we use nowadays, are going to be as okay multiple focus, which we call array transducers. We will talk in details about not only the fixed is going to be brought up in case another chapter and in chapter 12 as well. For all your different multiple focal transducers, how they work. Yes, okay, those details are going to be brought up in chapter number 12 as well. Okay, but the ones that we use in our labs are going to be as okay, what we call as okay multiple focal transducers or array transducers. But that's a discussion that we'll take up in those chapters. So that's okay. What is important now is okay as the diameter of the beam. Okay. So yes, okay, read on these topics, and it's okay. What we will do tomorrow is okay. Okay, yes, we just have a little bit of left, and then we can okay try to look at the questions in the chapter that we haven't done, and we can look at the chapter at the back of the book that we haven't done for this chapter there. Okay, does that sound like a deal? And then let's see what happens next. Any last word of wisdom? Nope. Okay, girlies, then have fun. Take care. And sorry for my outburst this morning, but I had to give it.
Thank you.
You're welcome, Jim.